Hello class, today we're on 2.5 Transformations of Logarithms. However, before we get to that, I want to add on to what we have of our rules of logarithms, because there are a couple things that came up. I was looking over the test and I realized there are two little kind of loose ends that we should kind of tie up and just, I don't want to make a whole lesson out of it, but just two important things to note. The first is I added another rule to our rules of logarithms, and that is the log of base exponential rule. And that says that if we have a log to some base and to some number, and that number is to an exponent, and the base and the number are the same number, then that is equal to just the exponent. So what I mean by that is, say if we have something like log base 3 of 3 to the 5th power, well, notice that the base is the same as the number here, and that number is raised to the 5th power. The answer is just going to be 5. Okay? Or for instance, if we have log base 2 of 2 to the 10th power, our answer in this case is just going to be the power. It's going to be 10. So you will need that for your test for a certain question. So keep that in mind as well. Also, I just wanted to remind us that exponential and logs are inverses of each other. Remember, that's kind of how we got into this whole idea of logs and exponentials, saying that they're inverses. Now remember the relationship between inverses and their domain and range. This is something you will also need for the test coming up next week, and that is that the domain of 1 is the range of its inverse, and the range of 1 is the domain of its inverse. So for instance, let's see, we can say that log of x is this, well, let's see, f of x equals log of x, right? And its inverse, which let's see would be 10 to the x, or sorry, hold on, I didn't give enough space here. And its inverse would be f of x equals 10 to the x, right? You can do that with if you're just to look at the log and exponential form. So these are inverses. So the domain of this 10 to the x is the range of the log of x. The range of the 10 to the x is the domain of the log of x. So just keep that in mind. You'll need that information as well. But getting into today's lesson, transformations of logarithms. So transformations, remember what that is. We dealt with it on our last unit. It changes the placement or the shape of a particular function. And one of those things that we dealt with specifically was translations. Remember, translations move things left or right, up and down. And we're going to talk about translations of logs, but I also want to add one more thing to it, and that would be reflections over the x-axis. So this is the general form. We have some plus or minus. I mean, if it's plus, you won't see anything, but sometimes you see a minus log, so I just wanted to include that. Log base b of x minus h plus k, where, remember our friends h and k. H, if we remember from last unit, moves the function left to right, and it's the opposite sign. That's the same case with logs as well. The h inside the parentheses, remember, will always be in parentheses, moves it left and right, or the graph left and right, and it's the opposite sign. K moves, or translates, up and down, and that's the same sign. So remember, the number outside of the parentheses, that's what shifts the graph up and down. The one I wanted to add was this plus or minus. Now, if there's a plus in front of the log, nothing happens. But if there's a minus in front of the log, if there's a negative in front of the log, then the graph is reflected over the x-axis. So that's just something to remember. So again, if there's a negative in front of the log, the graph is reflected over the x-axis. So let's get into some practice problems here. Give the transformation from f of x to g of x. So we're given the parent function f of x. Remember, a parent function is just the simplest form of a type of function. In this case, just log to the x, or log of x, would be the parent function of a log function because there's nothing really else happening to it. It's not being reflected, it's not being shifted left or right or up or down. It's just the basic form of a log. So f of x is just log base, in this case, log base 2 of x. In g of x is log base 2 of x minus 3 plus 1. Well, looking back at our general form up here, it looks like this 3 is going to be our h, and the 1 is our k. So it's x minus 3, which means it's shifted to the right 3 units. Remember, it's the opposite sign. It reads as negative, but it shifts to the right. So what we would say about this would be it's translated. Remember, translated just means shifted or moved. Translated 3 units right and 1 unit up. The k is the up, right? And the k is the same sign. So k will always be outside of the parentheses. H will always be inside the parentheses. That's how you can tell the difference. Let's take a look over here now. And so this is just log of x, which means the base is 10, right? Because it's not written. So log of log of x is plus 2, right? So notice there's no number, there's no parentheses, first off, and there's no number in the parentheses. X doesn't always have to be in parentheses, but if there's another number written, like an h, it'll need to be in parentheses. But this just means that there's no h value, or rather h is 0. So this isn't being shifted left or right at all. This is only shifted up 2, because this is our k. And I know, again, it's k because it's not inside parentheses. So this is translated, or shifted, or moved. You can use either. Translated up 2 units, just like that. Okay. Let's go down to this one over here. Ooh, I actually never finished this one. Okay. So this one, our parent function, our f of x, is log base 5 of x, and our g of x is negative log base 5 of x minus 4. So here we have an h. We don't have a k. K is technically 0, but we do have this negative as well. So remember what the negative does. It reflects over the x-axis. So we would want to mention that. So we can say it's translated, let's see, 4 units, and it would be 4 units right, because it's the opposite sign. So it's translated 4 units right. It's not translated any units up or down because there's no k. And it's also reflected over the x-axis. So we do need to mention that. So those are the 2 things that's going on with that one. Okay, we have one more example here. Now we have f of x equals log base 3 of x, and g of x equals 4 minus log base 3 of x. So notice the placement here is a little different this time. Our number, well, our k value, the value that's not inside parentheses, comes before the log, and that's okay. Sometimes we can have the number, sometimes we can have our k value before the log. It's still a k because it's outside parentheses, okay? So this is our k. And it doesn't look like we have an h because there's no number inside a parenthesis, right? It's not like parentheses x minus 5 or something, you know. So let's talk about translated. Well, this is translated up 4 because I know there's not a plus in front, but right, there should be a plus. I mean, it's an invisible plus. So let's see. We could say it's translated 4 units up. And just because the 4 is in front of the log, it doesn't change the function at all, or it doesn't change the graph of the function at all. It's just swapped. We can do that with numbers, right? For instance, 3 plus 2 is the same as 2 plus 3. It doesn't matter what order they're in. It's just the exact same thing. But also we have this negative here in front of the log. So the negative only matters if it's in front of the log in terms of reflecting. So this is reflected, so we also want to mention how it's reflected over the x-axis. And there you have it. Those are the examples, and that's transformations of logarithms. So that's all I have for you. Keep in mind the extra rule that we added today, and just the idea of inverses with their ranges and domains being swapped. Okay, so you'll need those 2 pieces of information for the test next week. All right. Wait, next week. This week. Sorry, I'm recording this on a Friday, but we'll be doing this on Monday. So this week, I mean. Okay. Have a good one. Bye.